Hi, everybody. Welcome to part 6 of step 3 of where we write your parabola story. Okay, you are at the end, y'all. This is question number 14. All you have to do now is write your story and explain your story in the context of the key features. So let's go ahead and look at an overview of what we're going to have to do on this part. So you're going to imagine a story for your parabola. What is the scenario you imagine? Include all details of the story, including any numbers or values necessary to make your problem make sense. Explain your input and output in the context of your scenario and why your domain and ranges make sense. Range value makes sense. What does your extrema mean for a particular picture with your given scenario? What does your y-intercept represent in your given scenario? Does this make sense? What does each of the roots represent in your given scenario? If one or both roots don't make sense in context, explain why. All right, so let's get started with writing our story. First, I want you to get a little bit of inspiration. So to get some inspiration, I went to Google, Google University. And what I did was typed in quadratic word problems, and my picture was a bridge. So we could take a look at my picture here. It's a bridge. This is the bridge in Paris. All right, so I went here to kind of get some ideas on how to write a word problem. Now look, I am not going to plagiarize anything. So do not plagiarize, but I do need to know some real life context of how to write my word problem so that it makes sense. So I went and found me some inspiration. Now that I got my inspiration, I'm going to go ahead and write my word problem. Truth of the matter is, bridges are everywhere, and there is a ton of math in bridges. There is parabolic curves. There's trigonometry we could look at. There's a ton of math involving with bridges. There's triangles, all of that. So I am not surprised that a parabola can describe a bridge. And so that's what we're going to use to describe the bridge in my picture. And in fact, parabolas or bridges usually follow a parabolic structure because it evenly distributes the weight of the cars and the vehicles and the people on top of the bridge. So it evenly distributes it so that the pressure doesn't succumb, so the bridge doesn't succumb to the pressure. So let's go ahead and write our word problem, okay? So I'm so excited, y'all. All right, so here we go. Our parabolic bridge, try to say parabolic 5 times, is 58.58 meters wide. You're probably wondering where I came up with that one. So let me go ahead and explain why I came up with that my bridge is 58.58 meters wide. So first of all, let's talk about my numbers. If you remember correctly, my numbers are in the single digits, right? It's like 2.4.7.2, right? So for me, my numbers don't make a whole lot of sense unless I multiply it by 10. So when I write my problem, I'm going to describe it as my graph being multiplied by 10. So instead of 2, it's going to be 20. Instead of 4, it's going to be 40. Instead of 6, it's going to be 60, right? That's the way I'm doing my increments here. So the other thing that I realize is if I'm saying that this represents the curve of the bridge, that means that this represents how wide the bridge is, and this represents how tall the bridge is. I don't know if y'all can see that one, how tall the bridge is. Okay, so I'm ready, y'all. Let's go. Okay, so let's talk about now how tall the bridge is. So it's 58.58 meters wide along, and I'm gonna say along the inner edge. Along the inner edge. And here's another reason why I'm saying along the inner edge if you look here on my graph, right, this is I was following the inner part of the bridge anyway when I was coming up with my points when I first started. So that's the inner edge. This is along the outer edge. This is the inner edge. So that's why I'm saying along the inner edge. Also, if you look at my x-intercepts, which is right here and right here, you will see that there's a distance between here and the outer edge, that distance right there. Well, that will make sense, more sense, being that my x-intercept is 1.273. And we'll talk about what that means in a little while. Okay? So that's why I'm saying along the inner edge. Now let's talk about the height of the bridge. The height of the bridge is 26. Now remember my height, my vertex was 4.25. Oh, I need to use a different color. 4.252 and 2.692, right? So I'm getting my height from there. All right. And so, like I said before, I'm multiplying by 10, which gives me 26.92 meters. All right. And so I'm going to now say that the bridge can be modeled by the quadratic. And I don't even have to say by the quadratic. I could say by h, right? I could say h of t equals, and then write our equation. So negative 0.30337 x squared, okay, plus, and the other values you can go ahead and get from Desmos. So hold on. So I changed it from h of t to h of w, where h stands for height and w stands for width. And you can even say that, right? Where h is the height and w is the width. And both measurements are in tens of meters, right? Somebody will say thousands of meters. I wonder if we could say tens of meters or something like that. So in tens of meters. That probably doesn't make a, I don't know if we could do that, but I'm going to do it because I need to multiply my numbers by 10. And voila, here I have a story now. I have my equation in there. And now I'm ready to go ahead and go on to the next part. All right, look out for the next video.